Howdy, Mark Serbu, gun designer, gun nut. In the last video, we talked about the new handguard for the BFG-50A, and I realized that we didn't really talk about what a BFG-50A is. Of course, if you don't know what this is, you probably didn't watch that video. But here's a BFG-50A, and here's a handguard for a BFG-50A. This is the original handguard, pain in the butt, welds all over. This is steel. It's kind of thin gauge steel, but it's strong stuff, but a real pain to make. And then here's the new handguard that we had in the video. This is an aluminum extrusion. And yeah, you saw it has all these things that attach M-lock attachment points, you know, M-lock slots, whatever. And this still is not the final configuration. It's gonna have more slots, but we're gonna talk about the ins and outs of this. We're gonna take a deep dive and look at what makes this new handguard new and cool. Before we take the deep dive, you gotta put the thing together so you can see the new handguard versus the old handguard, and I'm gonna do that for you really quickly. Now in production, of course, we're going to have like a piece of rubber or a piece of plastic in there that actually acts as guides for these spokes. It's going to make it a lot better, a lot easier, and it'll also help to dampen the thing when a round goes off. Because people were bitching, oh, is nothing going to ring like a 3-prong flash hire? It's like, well, maybe, but not if you're holding on to it. That works, or if we put one of these little damper spoke guides in there, that'll do the job also. Okay, so got the spokes in, gotta tighten the spokes. Oh, I didn't get that one in the hole. That's a funny one. Yeah, this is cool and awesome. It's just not yet. Yeah, the thing about this is that you are this takes a few minutes to put together, but compared to welding a handguard together, this is so fast. So much faster. And like I said, we're going to have a guide in there, so this will all be not automated, but pretty close. Yes, they're all in. Now here's the cool thing. Handguard is together, and remember how we learned about this last time, how these actually have to get tuned. And obviously I'm just tightening by hand right now. But still, yeah, those are pretty low pitched. I'm gonna get that one, bro. Okay, so here's a handguard all together. And the astute among you may notice that this is actually not a part of a handguard. This is actually part of the rifle. This is called the Trunnion. This is welded into the receiver. Now I just got it here just to mess with, because as I pointed out in the last video, this is a brand new way of doing this. In fact, do I have an old crappy one? Yes, hold on one second. Yes, here's one of the old crappy castings. Yeah, it's not crappy, it's cool. I like the look of as cast, and probably a lot of you guys do, especially like the World War II guns. Sometimes they're kind of just rough and they did it in a hurry, like there was a war on, and that's the way this has been for years. But and now it's all shiny and cool, and we talked about that. It just makes it more, it's more accurate. It makes it easier to do follow-on operations and stuff on the actual part. But anyway, so this is this part right here, this part of the rifle, and the old handguard, this actually had to go, and yeah, of course that's why this is sitting around. It's a lot of spec. This gets shoved on here, and there's a nut that goes on there and holds it in place. So the thing about this is it's got a rear flange, the old handguard, and it's got a front flange. And the front flange doesn't do anything except just kind of exist. It just kind of closes out the front, and it's welded on there. Now, the front flange on this one, this is key to making this work, because this front flange is where all the spokes mount. And you can see these spoke nuts. These are kind of like exactly what's on a bicycle, and they're what we tighten to pull the spokes in tension. And as you saw, they attach to the trunnion on the other end. And again, there's going to be 1,000 pounds of force between 1,000 pounds in tension on these wires when we tune them up to, I think it was middle G sharp on the piano, something like that. All right, so I'm taking these are actually Torx heads. These Torx screws. And they're literally, these nuts are literally off of bicycles. These are for bicycle spokes. The spokes in here are not literally bicycle spokes because I made them myself, but they're very similar to bicycle spokes. The problem is they didn't make them long enough when I first started doing this stuff. Nowadays they make longer bicycle spokes, but I don't know if that's going to matter or not, because we can always just make them ourselves, no big deal. But anyway, the cool thing is this even though this seems a little tedious, it's a hell of a lot better than doing all this welding here that takes forever. And it's also versatile. You can have different length extrusions, different wires. Okay, so a lot of you are interested in this. This is the end flange, and this is obviously what sandwiches the whole extrusion. You know, between you're sandwiching the extrusion between the trunnion and the end flange with the spokes. So each of those spokes is pulling 1,000 pounds, as we said in the last video. So you've got all this. You got 6,000 pounds of force on this flange, sandwiching the extrusion in between the trunnion and the flange. So the flange was just machined. I just hogged it out of a block of aluminum, which is not the most efficient way, but this is a prototype. And in production, this will actually be a whole different extrusion. This extrusion is just this shape, 10-foot long sections of it, but we'll get the same thing with this, and it'll just be same outside contour, but the inside contour is what you see here, and then we'll have to drill little holes in. Actually, they might even be able to extrude the holes in. That'd be kind of cool. But it's just a way to save time in manufacturing, and you end up with a perfectly, as good as hogging the whole thing out of a block of aluminum, but just a lot less time. And talked about the trunnion before. You can see the differences, and mainly these are mostly lightning holes just to make the part lighter, because it's a big old chunk of metal, chunk of steel, and the lightning holes kind of got in the way of where the spoke thread holes are, so I had to just rearrange them a bit. And anyway, nice looking part though, huh? Very shiny. That's why I do this stuff, folks. I like shiny metal. It's just the way I am. So talked about these Torx headed actual bicycle, these are what are on your bicycle wheels. Most of them have just like a flat blade screwdriver head on them. This one has a Torx head just because it's easier for us to use than a damn screwdriver. And you can get these anywhere, but this is nice because this is a part we don't have to make. This is off the shelf. You get them through Amazon even. But these are a little special right now. As I said, spokes don't come in this length. This is a really long spoke as far as bicycle spokes go, because bicycle wheels, this is 14 inches long. You'd have to have a bicycle wheel this big around. Well, now they have them, but they didn't when I started doing this. So anyway, I'm going to show you how I made these, how I put these crazy tiny little threads on here. Okay, the first part of the handguard assembly we're going to talk about is the spokes. Now these are the ones I made before, and I've talked about that. Crazy threaded ends. And what I made them from was a 4-foot long piece of music wire, and this is obviously way longer than any bicycle spoke in existence, except for maybe those old bicycles from the 1880s or whatever, the giant front wheel and the little tiny back wheel. Anyway, we have to cut this to length, dress the ends a little bit, deburr them, and then we run them in this little threading machine. And we're going to take a look at that threading machine right now. That's a pretty interesting little thing. Okay, I lied. We're not going to go look at the cute little threading machine yet. I have to cut this thing to length first. Nothing fancy, just marking it with a Sharpie. Obviously, in production you're not going to do this, but in production we'll probably have these made for us. I've got my little mark. Put my glasses on so I don't get lots of sparks in my eyes. And here we go. It's going to be loud. I just remember this should harken back to the video I did, that crappy rifling video where everybody freaked out because I was cutting something actually bigger in diameter than this. with this cutoff wheel, and they're like, oh, you're gonna cut your fingers off, and hey, guess what? I should go. Anyway, so there we go. Got our cut to length little piece. I'll probably go and deburr this, and then we'll come back and thread it. All right, so I've got my music wire marked, and I just stick it in the cool little spoke threader, tighten the collet, and go to town. Now this is obviously painfully slow, and they make much cooler, much faster machines, but you know, for just prototyping this is all I needed. And in production, we'll probably get someone else to make us the spokes, because we are not a spoke production shop, believe it or not. Yeah, they've got these really neat ones that are really high dollar, and you just put the wire in there, and you can cut the wire to length. You just turn a crank or push something, and just rolls the whole thread just really fast, really neat. But I don't think we're ever going to make spokes in production. And there you go. Perfect spoke. Okay, the next part is the handguard forward flange, but we're not going to talk about that much because we already talked about it. It's aluminum, remember, hogged out. It's going to be an extrusion eventually, and for now it's hogged out of solid bar. And there you go. Handguard and flange. Next is the handguard extrusion. Obviously this is the biggest and the main part of the whole handguard. And most people recognize extrusion from the old Play-Doh that we used to play with, the Play-Doh extrusion set. In fact, I was looking at it on my phone just to make sure they still had it, because you know I'm old and we had different toys back then, and they still make them, and they have some pretty cool stuff. Anyway, I was looking around, and sure enough, they still do have Play-Doh extrusion things. It's different than what we had. We didn't have these little, who cares, right? But they've got one that's, you got to see. It's pretty odd, and don't let your kids see this, because even though Play-Doh makes it, I don't think this is actually appropriate for kids. I'm serious, look at this thing. I don't know what to say. That's pretty weird. Anyway, so that's extrusion, and basically you're squeezing a material out through a die. And here you put the Play-Doh in and you push the handle down. But in here with aluminum, it's a little bit different. You've got to heat the aluminum up. You've got an incredible amount of pressure forcing this through the die. And the weird thing that most people, if you think about it, it's like, well, wait a minute, how on earth do you have a die on the inside and on the outside when you're extruding? Because how is that inner die held? It's like, yeah, that is kind of weird. It's like, it's either held by magic, or what really happens, it's held in place by a almost like airplane wing shaped thing, so the aluminum can flow around it. And the aluminum flows around it, and it's not quite molten, but it's heated up, so it's kind of pliable, obviously. And it goes around these mounts for the inner die, and it kind of flows back in, and it's pretty crazy how it works, and it looks beautiful, and it's perfect, but yet somehow it flows around those supports for the inner die. But who cares about all that stuff? What we have here is a beautiful extrusion that's what we call net shape, as far as the cross section, this hexagon shape. A lot less work than the old school steel one, and it has some other great features that I talked about before. We've got the thickness that allows us to use the M-lock slots. There's the old handguard was actually too thin for that, and now we've got the ability to have much longer, much shorter, whatever the hell we want to do. So, aluminum extrusion. Okay, well, I hope you enjoyed the deep dive, which is deeper dive. I mean, I'm not going to go into total nitty-gritty of every bit of it, but hope you learned some stuff here that you didn't know before. Let me know in the comments if you didn't, so you can bitch at me and make me mad at you. But really, got any comments? Is there something you didn't get? Is something you want me to talk about next time? Or did we cover this to death and you already know everything? I think you know everything. As much as you need to know. Let's put it that way. Thanks for watching. Appreciate you as usual. Catch you next time. By the way, somebody in the comments was saying that they weren't getting notifications of my videos. Can you believe that? Like, YouTube doesn't like me or something. So if you didn't get notification, even if you're subscribed and you click the little bell and everything, let me know, because it's pretty annoying. I mean, not anything I can do about it, but I'd just like to hear anyway. Thanks for watching. See ya.